Hi, everybody. We're back again, and today with us is Mr. Bruno Johnson, the CEO of Cascoda. Hello, Bruno.
Hi, Sasha.
Nice to have you here. And maybe before we get our hands dirty, we can start with a little introduction, maybe a little bit about yourself, about Cascoda, how you came to be in the KNX world, maybe also a bit about KNX IoT. What are some of the pros, the cons, and how do you see the standards developing in the future?
Okay, so yeah, thanks so much for that, and thanks for the opportunity. So I came into this world of KNX through the communications side. So originally, I'm a semiconductor design engineer working on communications technologies. I co-founded Cascoda, and at Cascoda, we set to create standards-based internet protocol connectivity for IoT. And that we've done very successfully. We've got a series of patents around a new type of radio receiver architecture that we can apply to the standards that exist in IoT. And we have since developed a full stack development capability. So we're able to design and develop both network layer and application layer stacks. And this led us to winning a contract with the KNX organization to write the open source software stack for KNX IoT. So this was a big job. It took us around 9 months, but we completed it on time and to schedule, which we're all very much delighted about. We work very closely with the KNX staff. KNX has some tremendous technical staff of their own. And so now KNX IoT is real. There's a software stack that is open and available on GitHub. We're pushing it out now to the community, both the KNX community and to the community of people like us who come from more the communication side of things to come into the world of building automation and home automation. So a little bit about KNX IoT itself. It is actually quite a beautiful thing. It implements KNX over Internet Protocol v6. So it's not just wireless. It covers all IP connectivity segments, Ethernet, power over Ethernet, Wi-Fi, Thread, and of course cellular. So we're able to use KNX across a building's or a home's IT infrastructure, and we're also able to use cellular infrastructure for our KNX connectivity, which is completely new. And the other amazing thing about KNX is that it uses the best and latest security standard. And this is a secure version of CoAP called OSCore. It is an IETF specification. And as far as we know, it's the first IoT standard to implement OSCore. So that makes it very lightweight and very efficient in the way it uses the bandwidth available, which is tremendous for Thread. As far as disadvantages, I don't think there are any disadvantage with KNX IoT over anything else. It really is the latest and greatest that we have. The specification is a fantastic piece of work, led by some of the board members of the KNX Association and the KNX staff. We got involved a bit later, but we have been involved in finishing off the specification as well. And KNX is really more of a professional connectivity standard rather than a consumer connectivity standard. But KNX IoT starts to open up the world of consumer IoT connectivity for KNX. So that's my overall summary.
Sounds pretty promising, and thanks for this intro. And now let's take maybe a step back now. Mm-hmm. Wired standards, wired smart home standards are becoming a standard in many new buildings. But, mm-hmm. We both know that this is not where the real smart home adaptation is going to happen. Now, we have like approximately 1.5 million new buildings or households being built in EU each year. And on the other hand, we have 200 million existing, mostly smart retrofit ready apartment just waiting to be converted into smart homes. And,
Yes.
like that's like a 150x larger market with an arguably faster turnaround. So why do you think this is not happening yet?
So I think certainly there's a huge need. One statistic I'm firmly repeating all the time is 35% across Europe. 35% of our buildings are over 50 years old. It's a fact. We're not going to take these buildings down. They're perfectly fine. And 75% of our buildings are energy inefficient. So that goes across homes and commercial buildings. In fact, in London, there was a study by Carbon Intelligence that said that 84% of a commercial buildings energy consumption was still consumed during April 2020 when the buildings were completely empty. It's insane. So the retrofit market is clearly the biggest market, and it's also the biggest need. But until now, it's been very difficult to retrofit buildings and our homes. The technologies that have been used in the past are many, and some of the standards that were used in the past are little supported and little known. So we really need a way to have new technology, perhaps IoT technology, communicate seamlessly with existing technology in a more brownfield environment. And that's one of the things that KNX IoT helps solve, because it uses the same semantics as KNX. It is KNX over IPv6. So you can have existing KNX technology talk with KNX IoT almost seamlessly, and the tooling such as ETS, the installer tool, and also the user interfaces won't see the difference between KNX IoT and KNX. So yeah, that's one of the big advantages. And so we hope that with KNX IoT, we start to make some inroads into that. At the moment, only about 1% of our buildings in Europe are being renovated each year. And to have any hope of hitting our carbon targets, we need to raise this up to something more like 5 to 10%.
Exactly, I agree completely. But we both know like this KNX IoT is not actually the first attempt by the KNX Association to, move into the retrofit market. For example, we had the KNX RF in the past. I mean, we still have it. And that, in my opinion, did not gain a big traction on the market itself. So why do you think that is? And, how will KNX IoT avoid a similar destiny?
Actually, that's a great question. So I would argue that KNX RF wasn't really a concerted effort to get into the retrofit market. It is useful where you need a limited number of switches, let's say, in places where they need to be battery powered. But there's some physical limitations about the sub 1 gigahertz radio band that are really not widely known or appreciated. So this might get a little bit technical, but there's a 1% duty cycle limit in the sub 1 gigahertz radio band in Europe. So you only have 2 radio channels, and you've got a 1% duty cycle occupancy limit. What that means is that you can actually only communicate for 36 seconds in 1 hour. Now, if you scale this up, it also shows that you can only get a limited number of devices interoperating in the same space at any one time. And the people who have experience installing KNX RF say that there's a practical limit of the number of we would call them nodes, but number of devices that can interoperate, about maybe 15 or 20. So yeah, there are some advantages of the sub 1 gigahertz radio band. The lower frequency radio signals penetrate and pass through materials such as walls better. But this limitation on bandwidth and the limitation on the duty cycle means that we simply can't get the density of devices that we need in today's buildings. So yeah, it's great for a fancy bathroom where you need a switch on a wall or on a piece of glass. Yeah, and you can do several of those, but it's not a technology that's suitable for completely refitting an entire building or a home.
Yeah, many RF devices in a single setup will cost like instabilities.
Yeah. Exactly.
Multicast RF helps, or?
Yeah, well, so KNX IoT, it uses because it's based on IPv6 rather than a single radio frequency connectivity technology. That means it can be used over any of the available transports. So you can use Ethernet where it makes sense to use Ethernet, and then only in a particular location where you want to have your wireless or you need to have your wireless connectivity, you can put a small hub there, and then you can communicate to the devices either using Wi-Fi or Thread. Now, Thread allows for hundreds of devices, and this has been done. There's a department store in Paris which uses Thread on all the coat hangers, and there are literally thousands of individual garments in this store, and it's really smart. You pick the device up and you can interact with the coat hanger, so you can ask for a different size or check stock levels and this kind of thing. So yeah, Thread allows for thousands of devices in one space, and it also forms a self-healing, self-managing mesh network. So the installer doesn't need to know about how Thread works or what it's doing, provided it's sitting there on the internet protocol on the IT system and can be seen by the IT guys as an IPv6 address. Then KNX IoT will be able to work with it, onboard it, and use it, whether it's a sensor or actuator.
Okay. Compared to KNX RF, what is the benefit of KNX IoT for the end user, for the customer on one hand, and for the manufacturer on the other hand? And will there be more KNX IoT devices or products than there were KNX RF products?
So a couple of things here. I'll start off with the will there be more KNX IoT than KNX RF? Well, time will tell. What I can say is that at the ISH trade show in Frankfurt 2 weeks ago, Siemens showed a series of KNX IoT products. So that's the first time that one of the giants of our industry has publicly shown a KNX IoT product. And to me, that shows real commitment by Siemens to bring products to market, hopefully this year. Cascoda has been demonstrating KNX IoT since the Light and Building trade show in October last year, and also at the ISE trade show in Barcelona, where we met. And so we have a number of customers who are designing KNX IoT into their products. However, there is no certification program open yet for KNX IoT. So you're not going to be able to buy a certified finished KNX product that you can put into your building right now. The test specification has been completed. Cascoda was involved in that. And the certification program, we hope, will be launched towards the end of this year. But that's not a question for me. That's a question for the KNX Association. Yeah. And then will there be more products of KNX IoT than
KNX RF?
KNX RF? I think so. I would put money on there being more products probably by the end of next year than KNX RF, based on what I can see that's going on in the background.
Okay, you already touched a little bit on my next question, which was like, how many devices can we see on the market and when? But let me maybe rephrase this question just a little bit. So, like, when do you think we'll have enough devices on the market or enough KNX IoT products on the market to be able to fully retrofit a modern apartment with KNX IoT? Exclusively.
So this really depends on a number of manufacturers getting involved, I would say. I think there's a good chance we'll be able to do this in around a year's time. Because different manufacturers have different specialities. And so we need a variety of manufacturers to be involved to achieve this. It could be that Siemens are working on a complete ecosystem of devices, in which case it could be sooner. Yeah.
Okay. Now, I'm sure you get this all the time. And, I already had a similar question at ISC. But nevertheless, like KNX IoT and Matter are both using Thread for communication. So
yes.
What are maybe your thoughts on the Matter standard?
Okay, so first, one of the fundamentals that's often misunderstood. Thread is a network layer technology, just like Wi-Fi. So that means that a Thread router or a Thread border router, and a border router is what takes the wireless side of Thread over to Ethernet or Wi-Fi. A Thread router will carry the data of any application protocol. Indeed, KNX uses different application protocols. DNS is an application protocol that's used by a higher level application protocol, such as KNX IoT. In the case of KNX IoT, it's multicast DNS, MDNS. Some standards require time coordination and time stamping. So you've got NTP. So yeah, the basic infrastructure of Thread will carry both protocols at the same time. Now, that doesn't mean that the end nodes will be designed to cope with both protocols. Probably not. So you can think of Thread as an infrastructure that we can put in our homes and in our buildings, and you can have a Matter device and you can have a KNX device, and the communication with them between the client and the server will be totally secure, but the information will simply be carried across the network. Having said that, KNX has a professional installer tool, which is owned and manufactured by the KNX Association itself. And that's quite an important thing for building automation, because every single KNX device that's ever been certified, going back 40 years, is there and will be maintained. So that means that if we put a piece of infrastructure in our buildings, a KNX IoT device, and we come back in 30, 40 years' time, this Thread, KNX IoT, let's say Luminaire, will still be available in ETS. And that's really important for a professional environment. Yeah. So every certified device is guaranteed to be maintained. It's not quite the same in the consumer environment. If the company that's making a consumer-based product decides no longer to support it, as we've seen with many consumer-based technologies, then it can be quite difficult to use after a period of time, especially if the security standards regarding it start to become outdated. So that's essentially the big difference between the two. With KNX, you are guaranteed that a certified device will be available through the installer tool, and you can reconfigure your environment using the installer tool even decades from now.
Yeah, so a guarantee of this longevity. So like, I agree,
Exactly.
This is really important. Now let's get maybe a bit more hands-on into KNX IoT. So, for example, how do you configure a KNX IoT product and then use it in practice? And how are the messages transmitted? And maybe, what are the dependencies?
Okay, so KNX IoT sounds like something totally different. And in terms of the connectivity, using Internet Protocol v6 is totally different compared to using wires. But apart from that, everything is exactly the same. So KNX IoT uses the same semantics. It uses the same methods and of messaging. And therefore, KNX IoT works with all the existing KNX tooling, such as ETS. So to configure a KNX IoT device, you just open up ETS, and even if you have a mix of KNX Classic, KNX RF, and KNX IoT devices, provided they're all on the network and connected properly, then you'll be able to configure them. As far as the installer is concerned, there's no difference. The installer will not see any difference.
Just business as usual, but a new set or a new range of devices.
Yes, that's right. Yeah.
Here's a wild idea. Would it make sense to bridge Matter to KNX over KNX IoT?
Yes, of course. There's no reason why not, and I'm sure people are working on it. So one thing that may not be that well understood is that KNX has a specification called the KNX IoT third-party API. So that's for third-party interfacing. So it provides a standardized method by which you can connect to and communicate with third-party protocols, including Matter, but doesn't have to be exclusively to Matter. There are plenty of other protocols. There are even smart city protocols that could be integrated through the third-party API. And third-party API, once again, is part of KNX IoT, and it's another beautiful thing in there. It provides a standardized method of discovery of the third-party clients and servers, standardized secured connectivity, self-description of an installation that works with ETS. So yeah, we have a means with the third-party API to be able to work with third parties. And I can say that at the trade shows recently on the KNX stand, there's been a KNX third-party API server has been demonstrated by Schneider Electric. So yeah, it's all there. The infrastructure's there. The standardized methods are there. So I'm sure people are working on it, and we are going to be able to see this and interoperate between the two, very soon.
And this also probably partly answers already my next question, which is like, what about the user experience? Because this is like what really matters to the user who doesn't know what is KNX or whatever. He wants like a good user experience, and this is my question. So, do you think that KNX IoT will rely on specialized KNX Visu products like we see today? Or will it be bridged to non-KNX apps through the API server? Or maybe there will be like new apps, new visualization apps developed specifically for KNX IoT?
I think all of the above. So once again, because KNX IoT is an internet protocol-based connectivity standard, we can tunnel KNX IoT through MQTT, the most popular backhaul that's used in for cloud connectivity. So that's one example where we can start to use the power of standardized dashboards and control systems in the cloud, and we can talk directly to KNX IoT because we can tunnel KNX IoT through MQTT, for example. Similarly, we can, because KNX IoT is IP-based, it works with cellular technology, we can start to use our phones to interact with KNX IoT and therefore our entire KNX installation in a way that was really quite difficult before. So yeah, the complete, what's the best way to put it? The complete infrastructure that we built for web-based connectivity can start to be used with building automation, really for the first time. And this is really very powerful, I think. It can allow for new business models, much more flexibility about the way we use our infrastructure. And remember, buildings are some of our most expensive and most valuable assets. We can start to reconfigure our buildings much more quickly. We can have much more flexible and short-term leasing. And all of this can be controlled through modern web-based systems that already exist on our phones, tablets, through the internet, and through web interfaces. So yeah, it's really exciting. I'm sure people are going to use this technology in ways that we have not even thought of. But you know, it's a wonderful opportunity, I think, for new entrants to come into the world of KNX and really transform the way we use our buildings.
Well, Bruno, thank you for this answer. And actually, I'm all out of questions. So, you know, like great talk, but maybe you have something to add for the end?
No, I don't think so. I think we've covered everything. I think there's one question maybe that is often asked, and that is, how do you connect KNX IoT to a KNX wired system? So there, as part of the KNX IoT standard, there is a portion of it devoted to KNX IoT with KNX Net IP, and that means that by using a KNX Net IP to KNX twisted pair router, which is a very small device that will fit on in a DIN rail. Usually just a one unit width. That's all you need. So you just plug Ethernet in one side, your twisted pair in the other side. Then, of course, your Ethernet side goes to your IT system in your building. So you might have, the building I'm currently in has various server rooms with racks of routers from HP. And it doesn't matter where you are in the building, provided you're on the IT system, you can then use KNX IoT to communicate through Net IP to your twisted pair system. So it is really that simple. And then, as you say, there are products out there that are very nice to use, like the Visu products from Jung. And yeah, that will work with a mixture of KNX Classic and KNX IoT technology, provided it's all been configured correctly using ETS.
The future looks bright.
Yes,
thank you for joining us. Thank you for taking your time. Thank you for sharing your wisdom. I think, like it's some great content that you shared with us. So thank you again. See you on the next exhibition probably. And for our viewers, thank you for taking your time. And, like always, comment, like, share, follow, etc., etc., and see you on the next podcast.